The FutuRaM project is building a knowledge base on critical raw materials, CRMs, found in Europe's waste streams. It focuses on 6 key streams: batteries, electronics, vehicles, slags and ashes, construction and demolition waste, and mining waste, each representing a significant source of CRMs. In addition, FutuRaM aims to support the development of facilities that can turn this waste into valuable resources. To do so, the project integrates its data with the United Nations Framework Classification for Resources, or UNFC, a system originally used for primary raw materials. FutuRaM adapted this framework for secondary raw material projects by developing a structured assessment process to evaluate projects across 6 criteria: level of confidence in the quantities, technological feasibility, and economic, social, environmental, and regulatory viability. It is also developing a national approach to apply UNFC. The project has tested this methodology in 19 case studies across the 6 waste streams at both site-specific and national levels, demonstrating how UNFC can bring structure, insight, and comparability to circular economy initiatives. Here we hear more from a few of these case studies.
My name is Serge Kimball. I'm CEO of the Recycling Group, specialized in refining precious and critical raw materials. We are working the FutuRaM project and presenting a case study which highlights a new plant being installed in our industrial plant in Normandy, which is dedicated to increase the recovery of critical raw materials, CRMs. And that's specifically for a specific waste stream, which is electric and electronic equipment and small appliance and IT devices. To enhance evaluation of our project, we choose to apply to UNFC. We had an internal review of our project, but we sought on an independent and standardized expertise and perspective. So UNFC was offering exactly that. So providing a structured and transparent framework to assess our initiatives. The advantage of using UNFC have been significant. It represents a global and recognized approach endorsed by European Commission and supported by EU broader's objective of strengthening CRM resilience. This methodology has not only validated our project current status or stage, but also enhanced, and it gives credibility within industrials and policymaking communities. Interestingly, applying the UNFC methodology and framework did not reveal unexpected results. Rather, it confirmed actually our initial assessment and strategic direction.
The Håkansboda case study explores the potential recovery of valuable metals, including copper and cobalt, from historical mining waste at the former Håkansboda copper mine in south-central Sweden. The project also investigates other economically and strategically important elements such as zinc, silver, gold, antimony, and bismuth, many of which are considered critical raw materials. This case applies to the United Nations Framework Classification for Resources, or UNFC, to bring structure and comparability to the assessment of anthropogenic mineral resources. Until now, there has been no systematic approach for reporting such projects. UNFC enables not only the physical and technical evaluation of a project, but also comparison across multiple projects and the identification of potential policy or regulatory barriers. One key advantage of using UNFC is its holistic scope. It considers both technical, environmental, socioeconomic, and sustainability factors together, providing a broader and more integrated view of project feasibility. A surprising insight from this application has been that there is a misalignment within Sweden's current permitting process. This process mismatch can force the UNFC to apply an overly conservative classification, since projects may prematurely appear legally unfeasible.
Yeah, and then you have a lot of...
I'm Julia Stegman. I'm Professor of Environmental Engineering at University College London.
And I'm Jonas Breidenbach. I'm a research fellow also at University College London. This case study evaluates the feasibility of producing mass timber, such as glue-laminated and cross-laminated timber from recovered wood sourced from construction and demolition waste.
It covers the full process, selecting feedstock based on quality criteria, pretreatment, treatment, and final lamination. The assessment, developed with UK CLT, a London-based R&D company and manufacturing startup specialized in mass secondary timber manufacturing, examines environmental, economic, social, and legal aspects.
The UNFC was used to provide a structured, multidimensional evaluation of this industrial upcycling process. It enabled transparent classification of secondary timber based on technical, economic, environmental, and regulatory feasibility.
For UK CLT, it helped assess material availability, market conditions, and legal challenges. The UNFC highlighted strong market interest and technical viability while also identifying barriers such as the lack of industry standards for secondary timber in the UK.
Notably, it exposed legal ambiguity around whether mass secondary timber production qualifies as reuse or recycling, impacting compliance and permitting.
Despite these challenges, the work serves as a foundation for advancing mass secondary timber as a strategic low-carbon alternative within the UK construction sector and a catalyst for material circularity at scale.
This case study focused on the rehabilitation of a former mining site affected by acid mine drainage. As a result of an earlier treatment using lime, approximately 150,000 tons of sludge remain on site. This sludge contains significant concentration of valuable metals, particularly copper and zinc. As a part of the rehabilitation project, FutuRaM is developing a process to leach and precipitate these metals, contributing both to site remediation and resource recovery. We choose to apply UNFC method because it is the framework proposed in the Critical Raw Materials Act. This project is an ideal case study, as FutuRaM controls key aspects. We manage the site, we develop the recovery process, our research and development activity, and we have also the leadership and the negotiation with companies for remediation and recovery activities. Using UNFC has been beneficial as it presents a structured method to assess controlling factors essential to a project success. It helped us identify pending questions and gaps in our internal evaluations. While no expected results emerged, the framework allowed us to prepare more effectively for future stages, such as environmental impact assessment, and encourage us to consider aspects that we had not previously examined.
Phosphorus recovery from sewage sludge is a growing environmental resource challenge. While wastewater treatment is essential to protect ecosystems, it generates large volumes of sewage sludge rich in phosphorus, a non-renewable but vital nutrient for agriculture. Improper management harms the environment and increases Europe's dependence on imports. In response, countries like Germany, Austria, and Switzerland have introduced legislation mandating phosphorus recovery. We examined 2 case studies to explore recovery options. The Renania process using Aztec is a thermochemical method that produces fertilizer with the sewage sludge, ash. It's cost-effective and relatively simple. Phosphor for Life, by contrast, is a wet chemical process that extracts phosphoric acid even from contaminated sludge, though it's more complex and capital intensive. We use the UNFC to summarize and communicate the information gathered from the case studies in a structured and clear manner. Tools like SARA, developed by the FutuRaM project, help track progress from concept to feasibility and to identify enablers and barriers to develop the project. It ensures transparency, consistency, and comparability, which forms the basis for evidence-based decisions. Our findings highlight the need for regional coordination, as individual wastewater treatment plant operators often lack the data needed for sound planning. At the national level, a coordinated assessment of sludge compositions, infrastructure, and recovery potential can guide investments and make it aligned with circular economy goals. In short, a UNFC-based approach empowers smarter decisions, stronger collaboration between stakeholders, and with that, more sustainable phosphorus recovery.
The results of the project will provide invaluable support to policymakers and governmental authorities in this crucial area, as well as having the potential to promote the recovery of critical raw materials. Ultimately, the success of FutuRaM will help to ensure a more reliable supply of critical raw materials and support the EU in achieving its green agenda.